Well, good afternoon. Wanted to follow up on our conversation last week about word problems. And to me, word problems are really an essential element of the challenges our learners struggle, not only because, of course, we test with word problems, we instruct with word problems, we're asking folks to pull out information from the word problems and the various equations that we've taught them, everything from decimals to fractions to pre-algebraic to algebraic, but also the language element. And as we mentioned early in our sessions together, that struggling learners, particularly those with learning disabilities, have gone from a reading writing literacy focus in terms of primary challenges to a reading math focus because of the language elements of math. And of course, our word problems are really where we're struggling there. So our second week kind of focusing on that, I wanted to go back to an element we brought up last week, and that was our last time we met, was our keywords. And I'm not trying to in any way, shape, or form say don't work with keywords. I think keywords are important. I think that for some of our struggling learners, we can really focus in on certain keywords. We can take a look at our curriculum and see how things are aligned and really focus in on particular keywords. But as an overall strategy for some individuals that have learning challenges and that struggle, keywords may not be enough because the inconsistency of the use of the words and at times what those words may very well mean may have double meanings, or depending upon the struggling learner, it may be perceived as having double meanings. And so that way, by saying, okay, look for this keyword and then turn this into an element of the equation, may not be perfect for our struggling learners with language concerns. So I'm not saying throw it out, I'm just saying some caution. And one of the reasons I'm reinforcing that is back to these idea of the strategy of mapping, as well as what I'll organize overall as an umbrella term, the schema. I really believe this is a critical element for so many reasons. I'm going to bring it over to the reading for the moment that we didn't talk about last time we met. And that is, in reading, we really focus in on strategies that allow individuals to be empowered in looking at their content for critical vocabulary and looking at their content for critical comprehension components to improve fluency. Now, we could talk decoding and phonological awareness, but we're not talking that age group, so I'll stop there. But I'll give you a reinforcement there. So we actually use schemas, just like you see here, in order to adopt, in order to support, in order to allow individuals to be empowered with pulling out keywords from reading. It could be science, it could be language arts, it could be social studies. And of course, we're going to do this here in math. We could do it in terms of, well, let's pull out this information to make comparisons. Let's pull out this information to make main ideas. Let's pull out this information to make comparisons in terms of compare and contrast. What similarities do they have? And so what we do is we give them a tool, and with that tool, then they could take it to a science book, to a social studies book, to a language arts book, and then use that tool across those content areas to pull that information out. So we're teaching them that tool. That's been very effective over decades of work. If you take a look at this reference, this is over decades of work as well. Schemas do very similar things, or that kind of overall idea of mapping strategies. And so what I wanted to do is spend a few minutes here reinforcing that, focusing on some ideas of diagram, mapping, ratio equations, and tables, and different ways to be able to give a schema to the individual. And then from that schema, and again, those schemas being used with technology like, I personally love Inspiration because I can color code it, I can pattern code it, I can allow for the arrows, I can structure it in a manner that it could be visual, in that beyond just simply the elements of circles and squares and rectangles, I could also offer a visual to make a representation. I can embed video to make a connection. There's a number of different things I can do to actually teach them the schema. And then, of course, when they're using the schema, it could be fairly basic. So I like that. But Inspiration, I really like. Of course, Poplet allows me to do it, explain everything, show me apps in that respect. And of course, as we're discovering, there are math apps that allow me to do that within the actual math component in terms of building out schemas. So let's go back to diagram here. So the diagram here, this idea that there's a small number and that there's a big number. In terms of the idea that, again, this is just one of several, but here we could say, well, the small number implies subtraction and the big number implies addition. And of course, then we set the equation from there. That might not be perfect for all individuals, it's just a consideration. Let's go to comparison problems, and here, difference between two values, right, are being compared, and we've talked about this previously. And in this word problem here, so we're thinking about the confusion possibly of number families, and we want to represent the problem, right, using the big number family. And students may determine whether each of the two numbers given in the problem, right, is a small number or a big number. And then they're shown a simple way to do this. And so this is just a simple way of breaking down the problem. Then we extend the problem in terms of the fact that we're looking for replacement there. In terms of that 112 we replace. And then of course it turns into an addition problem. And of course with the addition problem, we're able to get what we're looking for. Now we can extend this with this idea of, well, instead of numbers, we can take in the item, magazine, newspapers, and then we replace the item with the number. And then the number leads to the fact that it's a subtraction. And so that, again, the same type of structure, same type of mapping, and the individual just replaces that based on that mapping. Now, again, there's variations of this. There's a host of variations of this. And so it's, one, identifying some of those variations. And by the way, the visual I offered a few slides back, there's a nice article that talks about that. I have a link for that for you folks to take a look at. There's a number of reports on schemas for you to consider, and of those schemas, there's a number of different things to do, as I mentioned the last time we met. So it doesn't necessarily select one. It could be the overall idea, and then what adapts best for those students. And then, of course, teaching those students directly with that. So here we have the classification problems, right? And here we have the small numbers of factors, while the big number is the product. So we can do multiplication, division here. And here, the family, again, numbers, we're representing multiplication, division facts. And then we're looking for potentially here, missing small number implies division. A missing big number implies multiplication. So we're giving the students some clues. We're allowing them beyond just a keyword to make some to imply some things. And so yes, they have the schema or the map. Yes, they have the strategy, and then they have some clues to look for to then make some implications about what the actual problem will become. And so again, another consideration. So of course here with this classification problem, we're going to extend it. And here we're looking for, of course, 3 at the end. But in doing so, we're mapping it out. We're allowing them to choose the operation. And it's a strategy that goes beyond simply, oh, well, the keyword implies this. We're allowing them to analyze, and we're allowing them to hopefully reduce the likelihood of error with this type of structure. Now, stepwise here, we can take it and kind of extend it with a ratio equation. And here, again, we have 5 basic steps. But in those 5 basic steps, we're applying elements that we've been learning with fractions. We've been offering elements in terms of the language, pulling out the language and what it means, of course, in terms of our numbers. And then, of course, we get to our total that we're looking for. And in so doing, as I mentioned a moment ago, we're identifying what's our numerator, identifying what's our denominator. We're using the ratio element that we've been instructing with them, which we talked about a while back, that we could have used timelines, number lines and things of that nature to initially get them thinking about that. But now we're going to apply it within the language aspect of the problem for a word problem and come up with a solution. Now another ratio equation here, as you can see, same strategy, but we're going to do for division. So again, I'm utilizing elements that I've learned here. I'm going to apply it over here to division to be able to, again, get to my successful equation. And in doing so, I've given them an overall structure with some flexibility for several methods. Now another consideration here, of course, is that, again, I'm trying to use the same type of strategy. I want their confidence with solving the problem. I want them learning that several different methods are things that they can control, and they can see that success, back to that math anxiety we talked about a while back, and then, of course, down into the answer. All right, now, with that said, the last thing are tables. And the tables allow us to unpack information to get us into equations. And tables are useful for some word problems and not useful for others. Let's go ahead and take a look at this one. We're really trying to unpack a lot of elements here when it comes to paperback and hardback books. We're actually looking them into boxes, and there's some color to go along with it. And there's 4 basic things we're looking for. How many books are in the red box, which has more paperback books, how many hardbook books are in the red box, and of course the total number of books in both boxes. So our first one, we can map in terms of the table. We can put the information into the problem, right? And by doing the rows, we're offering a classification for the families, and each one representing the numbers, and then being able to apply those numbers into an equation. I apologize for the cloudiness of the slide in this instance. So we can move forward here, and in this instance, they complete the top rows now, and we start with a big number and subtract to complete the bottom rows, right? And in doing so, we get to the smaller numbers. And so we're breaking it down piece by piece, and then finally, they function as a number family, right, in terms of the columns, and now they subtract in order to complete what they're looking for. And so in doing so, we have our answers, and we have our solution, and we've organized it into a table. And again, this may not be relevant to some of the learners you're working with, but we'll get to the answer we're looking for. For me, and this was a very brief overview, and it was kind of a reinforcement to, again, the schemas we talked about last week. There are a host of schemas. Again, I'm offering a couple articles, very quick articles that kind of reinforce the differences in schemas. It breaks it down for the equations we're looking for, that and then immediately brings it into is it division, is it multiplication? Of course, we can extend it beyond that, as we talked about last week, last time we met. So it's just not addition, subtraction, multiplication, and division. It's organizing things, as we already indicated today, with fractions. It's organizing things into an equation that then we would need to solve. So again, the schemas allow the student some empowerment, some flexibility, some consciousness of the situation, some structure, and overall that independence that we're looking for to be able to apply across a number of different word problems. And of course, at the end of the day, it's dealing with the language, and the language is as equal much of a concern as it is the math. Hope this information helped. And again, I want to reinforce using tools like Inspiration, Poplet, Show Me, Explain Everything, and a host of other things that allow the student to visualize information. And I want to reinforce that because not only with math word problems is it very relevant, of course, some of the things we talked about earlier with decimals and fractions, those tools can be used for as well. But those tools are also being used across reading. Those tools are being used across writing, particularly in terms of brainstorming, organizing my thoughts, visually structuring how I want to sequence things. Well, let's use that tool also in math because, of course, now I can get it and I'm using it here. Well, I can then use it across several different content areas. So it's not a different tool per content area. It's instead it's the same tool I can use and become very efficient with and be very comfortable with to be able to apply it across different content areas. That to me is a kind of a twofer or a secondary outcome, but very positive secondary outcome. Hope this helped, and I hope you have a great rest of the afternoon.